All right. Well, today is, Halloween. I thought I can't miss this opportunity to make videos on Halloween. So here I am. We are reviewing antiderivatives with Shrek. So look, how do I do an antiderivative? And the key is to look at the exponent and add 1 to it, and then you divide by that exponent. And don't forget the candy at the end, plus c. We can reduce it down, but it's not necessary. Let's try that again. For this one, we want to write it friendly first. So 1 over x squared, we're going to write as x to the negative 2. And 3 and the square root of x, we're going to write to the 1/2. So we're going to write it exponentially. So then I can add 1 and divide. So add 1 to the exponent and divide. You can leave the answer that way. Next one, add 1 to the exponent. So we're going to add 1 plus 2. And then divide, and yes, you could write it like that, and don't forget the candy. One thing we're going to remember is that instead of dividing when you have a fraction is to go times the reciprocal. So another way to write this answer would be negative x to the negative 1, and in front would be 2/3. And then notice the 3's would divide out, and you'd have negative 2x to the 3/2 plus c. All right, number 3. How about trigonometry? What's the antiderivative of cosine? And the answer is sine. What's the antiderivative of secant squared? The answer is tangent. And then plus c. That's it. All right, number 4. Oh, can you see my Shrek stuff coming off here? The derivative, and you have a point. Can you find f of x? So antiderivative to begin with. What does that mean? You add 1 to the exponent and divide, plus c. And then we have a point to plug in. So this is the x coordinate. This is the y coordinate. That's what f of x is. That goes there. And then we solve it to know what c equals. I have a fly flying around. I think that's appropriate. So 1 cubed is 1 times 6 divided by 3, and then subtract 2. And in this case, c is equal to 0. So f of x then would be, and we can simplify this down to 2x cubed. And we don't need to do that, but whatever that number is, you would add it at the end. In this case, plus 0 doesn't change anything. But if it was a different number other than 0, you go plus or minus whatever that number is, and that's how you find it. All right, last review question. So acceleration and velocity and position are all connected to each other. So at first, we took the derivative to go this way. But if you're given acceleration, we're going to do the antiderivative to go backwards. So if I want to know the velocity, it's the antiderivative of acceleration. So again, we're going to add 1 to the exponent and divide. If it's a number, we just include, so negative 1 would be negative 1t, and then plus c. And then we plug in what we have. Now this means initial. So if we're not given this exactly, like on the quiz redo, it's initial. That means the number you put in for t is 0, and then this is what it's equal to. So 0 is what it's equal to. 2 divided by 2 is just t squared. Oops, sorry. 3 is what it's equal to. And then you plug in 0 for t, and then solve it. So in this case, c is equal to 3. So the velocity altogether then would be t squared minus t plus 3. Now, if I want to find the position equation, then I'm going to do the antiderivative of velocity to get the position. So again, I'm going to add 1 and divide, and then add 1 and divide, and make sure you go plus c. Whenever we have a constant, just put the letter with it, and you've done the antiderivative, and then plus c. And again, it's equal to 1, and you put in 0 for t. 0 is a beautiful number in math, and so all we're left with is c equals 1. So if I put it all together, the position equation would be t cubed divided by 3, t squared divided by 2, plus 3t, and then what we found, c is equal to 1. All right, there's your quick review on antiderivatives. Mr. GMath, over and out. Till next time.